This is section 6.4, solve compound inequalities. So a compound inequality is just two separate inequalities joined by and or. The graph of a compound inequality with and is the intersection of the graphs of the inequalities. So for example, if I know that x is greater than -2 and x is less than or equal to 1, I can say -2 is less than x, less than or equal to 1. So in other words, it's these two graphs up here merging into one. This one's going up, but it's going to stop where this one is limited. And this one's going to go down, but it's going to stop where this one is limited. Okay, so -2 is less than x, and x is less than or equal to 1. So in other words, x has to fall between those two values. So that's what an and inequality tells us. An or inequality, on the other hand, the graph of a compound inequality with or is the union of the graphs of the inequalities. So this one's going to look a little different. But to give you an example, if we know that x is greater than or equal to 0, or x is less than -1, it's just these two graphs merging onto one. So they're not coming together, they're literally just both on the graph. So x is less than -1, or x is greater than or equal to 0. X cannot be in between here. Okay? One way that I think about it, it's sort of silly, but if you think of an oar, like for a boat, like an oar on a boat, to row a boat, that's what these sort of look like to me. So if you have your little boat and then, you have your oars that paddle it in the water. Alright, so they kind of look like that. So just remember the or is separate. So they're not going to connect at all if there's an or in the inequality. Okay, our first example, I'm going to do it two different ways. It's totally up to you how you want to do it, whichever one makes the most sense to you. Notice it's all written as one nice statement, so I know this is an and compound inequality. And actually, the first way to deal with this is to break it up, to write it as two separate inequalities. So I could say 2 is less than x plus 5, and x plus 5 is less than 9. So now I'm just going to treat them the same way I did my multi-step inequalities. So I'm going to subtract 5 from both sides. And 2 minus 5 is -3. And again, subtract 5 from both sides. And x is less than 9 minus 5 is 4. Now, because it's and, notice that these two guys are kind of facing each other. You end up with an x here and an x here. So that tells me that I can combine it and write it as one sentence. So I can say -3 is less than x is less than 4. So since it started as one nice statement, I can finish it as one nice statement. And now to graph it, well, at -3 I have an open circle, and x is greater than that, so it's going to be above -3. And an open circle at 4, but x is less than that, so it's going to go down. And again, because it's an and compound inequality, I know that it should be connected. Now, the other way to go about solving this is to think about it, normally we talk about both sides of an equation or both sides of the inequality. The only difference here is that you're going to think of it as all sides. So instead of an equal sign there, it's an inequality, but if you sort of give yourself a divider to remind yourself, I'm fine with you doing it this way. So again, if I want to get x by itself, I want to subtract 5. Whatever I do in the middle, I got to do the outside. So -5 minus 5. 2 minus 5 is -3. Less than x, less than 9 minus 5 is 4. So just to rewrite that nicely, I end up with the same thing I did on the other one, just without having to put it back together. So again, I would have the same graph. They should be connected. Now, an example with an OR inequality, you cannot combine these because remember, they don't merge. They're just two sort of separate inequalities on the same graph. So this time I really want to keep it separate. So over here, to get x by itself, I'm going to subtract 3 first. I'm left with 2x is less than 6. Then divide both sides by 2, and x is less than 3. Then over here, I'm going to add 6 to both sides. So 3x is greater than 18. Divide both sides by 3, and x is greater than 6. Now this time, notice, these are not facing each other. So the x, it doesn't come together. X is over here, and x is over here. So I can't write it as one statement. They have to stay separate. Alright, so now for graphing, x is less than 3, so I'm going to have an open circle at 3. It's everything less than that. And then x is greater than 6. So again, open circle at 6, x is everything greater than that. Alright, one more example. Again, this time I have and I like the second way better. Whatever works best for you is just fine, but I'm going to make sure that whatever I do to the middle, I do to all sides. So, first thing I'm going to do is add 3. Add 3, add 3. Negative 5 plus 3 is negative 2. Is less than or equal to negative x. Do not leave that out. 2 plus 3 is 5. And now, x is not totally by itself. Be very careful. Because remember, negative x is the same thing as negative 1x. So to get x by itself, I'm going to divide by negative 1, making sure I do that on all sides. Negative 2 divided by negative 1 is a positive 2, but notice I divided by a negative, so I have to flip my sign. That becomes greater than or equal to x. And now 5 divided by negative 1, that's negative 5. But again, I divided by a negative, so I have to flip my sign. Now, that we can still interpret, but it looks a little different than we're used to. So we can actually rewrite this. This is the same thing as saying negative 5 is less than or equal to x is less than or equal to 2. So now to graph, I'm going to fill in my circle at 5, and x is greater than or equal to that. Fill in my circle at 2, and x is less than or equal to that. So because I have that nice and statement, I know my graph is going to be connected.